to today's presentation. We are Group 1, and our presentation is about AutoCAD, transforming design, engineering, and collaboration, the past, present, and future. My name is Morris Solano, and I will be doing the intro for our group. Next slide. So, a brief introduction on AutoCAD. If for those who do not know, AutoCAD is a computer-aided design program that helps in designing, designs. AutoCAD has been a cornerstone in the world of design and engineering since its creation in 1982. Over the years, it has evolved from a basic 2D drafting tool to a powerful software that integrates 3D modeling, automation, cloud services, and AI-driven features. In this presentation, we will explore the key milestones in AutoCAD's evolution, starting from the first version to the present-day version, its impacts on industries like mechanical engineering and architecture, and its role in modern collaborative design projects. We will also analyze its advantages and limitations compared to other CAD software, as well as its relevance in education, remote work, and future technological advancements. That's right, AutoCAD is such an important piece of technology that its application reaches beyond just engineering itself, but also many other important fields of work. Let us begin our report on how AutoCAD continues to transform design and engineering practices around the globe. Next slide. So, as I said before, we are Group 1. Here are our members, our handsome leader, Mon Viterbo, and we have six other members, Renz Villarvieja, Dominic Sabangan, Cyrus Tique, Jenilyn Aplacador, Camille Tea Folgado, and me, Maurice Solano. Very well then. Let's go to the next topic. The evolution of AutoCAD. So the evolution of AutoCAD can mainly be split into four periods, let's say, from 1982 to 1982 to 1999 to 2007, and then 2010 to 2017, and 2020 to 2023, and of course the present day. So let's go to the first period. Right? The first period was, let's just call it the period of accessibility, since it was mainly focused on that. AutoCAD was launched in 1982, specifically December 1982, as one of the first CAD design programs. As I said, CAD, computer-aided design programs for personal computers, revolutionizing the design progress. Before its introduction, CAD tools were expensive and limited to specialized hardware, but AutoCAD advanced the field by running on widely available PCs. Before the introduction of AutoCAD, if you wanted to use CAD programs, you had to use very high power and very specialized hardware, like what you see with old computers like the IBM and the ENIAC. But AutoCAD was the first one that was mainly available in common PCs, like the one that you are using today, except before they were less updated, of course. Mm. This period also saw the introduction of Autolisp, a programming language that automates design tasks in AutoCAD. Similar to how we design programs in C++ in the previous semester, AutoCAD uses Autolisp, a dialect of Lisp that is specifically for AutoCAD. Autolisp also extended and customized AutoCAD product functionality, and by 1992, 3D designs were added, allowing for more capable projects. Next. The next period was the period of efficiency from 1999 to 2007. As the user base of AutoCAD grew, Autodesk focused on enhancing usability and efficiency. The Design Center was introduced. The Design Center was a great tool that allowed for organizing and drawing content. It also allowed for DWG compression. Again, if you do not know, DWG is the file format for all AutoCAD programs, similar to how Microsoft Word uses docs and PDFs. AutoCAD used DWG, and the introduction of the DWG compression allowed for reduced file sizes for easier storage and sharing. During this time, enhanced 3D models were also introduced, which significantly upgraded users and allowed them to create even more realistic designs. Okay? And the third period, from 2010 to 2017, was the period of modernization. As, as AutoCAD grew, it also had to move with the times and other technologies. The technology that was introduced in this period was mainly the parametric design, which allowed users to define parameters, where its name has come from, and relationships between design elements. These parameters control how the design behaves when something changes. So before, when you wanted to change the size, let's say, of a design table, you had to manually move its geometry. But with parametric design, you could just adjust its variables and its various elements to move with how the other parts of the design moves. So let's say instead of manually adjusting it, you can set it to half of the length of the table and it would automatically adjust. This period also introduced cloud storage integration and PDF import tools, which made working between computers easier. It also introduced a mobile app, which enabled design even on a portable device. Okay, and the fourth period was focused on automation. The automation period mainly focused on, as it says, automation of design. It introduced features like Markup Assist and other tools. Markup Assist is a great tool because it allowed us to simplify tasks by automatically suggesting annotations to our designs. This period also introduced integration with various other apps like Google Drive, which made working between multiple people even more easier. And lastly, it also introduced a subscription-based model of payment, similar to Netflix, where you have to pay a monthly fee. In this period, AutoCAD changed its payment model into a subscription-based. Now, some people may not like it, but it allowed people to have the latest update in the same budget while also allowing for flexible budgets for other people. So if you were on a tight budget, you could pick the cheaper subscription model. And if you wanted more features and had bigger budget, you could go for a heavier and more extensive model. So it allowed people to be flexible with their purchases. So those are the five, if you count the present day, which is the evolution of AutoCAD. Okay. Overall, AutoCAD has had many different versions, around 25 or more. And if I counted all of them, there would be even more. So I'll summarize all this just for you. I hope you enjoyed. Okay, let's move on to the next reporter on the next topic. Impact of AutoCAD on mechanical engineering and architecture.
Okay, so this is the impact of AutoCAD on mechanical engineering and architecture. For mechanical engineering, we have precision and accuracy. With AutoCAD, you can create detailed 2D or 3D models for precise component designs. Next is rapid prototyping. AutoCAD facilitates simulations and testing before production. And lastly, assembly modeling. AutoCAD can visualize relationships between parts in the complex systems. A good example of this is that AutoCAD is used in the automotive industry to design engine components and optimize performance. While in the field of architecture, we have blueprint creation. It streamlines the creation of accurate architectural drawings. Next is 3D visualization. AutoCAD helps visualize buildings in realistic 3D for better client presentations. Lastly, Building Information Modeling, also known as BIM. AutoCAD optimizes designs for functionality and energy efficiency. A good example of this is that architects use AutoCAD for designing floor plans and 3D building models. Next, let us proceed to the AutoCAD in modern collaborative design projects. First, we have cloud integration. It enables real-time sharing and collaboration from different locations. Next is version control. It tracks changes and ensures the team works on the latest version. Next is collaborative tools. It allows comments, markups, and feedbacks to streamline communication. And lastly, we have integration with other software. It facilitates seamless teamwork across different design disciplines. For example, in large-scale projects like bridges or skyscrapers, AutoCAD has various teams collaborate on structural, mechanical, and architectural aspects.
So now, let's tackle and analyze kung ano nga ba ang advantages and disadvantages of using AutoCAD in comparison to other CAD software available in the market. So let's dive in the pros of using AutoCAD. Number 1, extensive functionality and versatility for 2D and 3D design. AutoCAD is very versatile because it offers both 2D drafting and 3D modeling features. This means that whether you are creating simple floor plans or more complex 3D structures, AutoCAD has the right tools to do the job. Sa AutoCAD, maaari mong maayos na mag-drawing ng mga technical details o mag-model ng mga 3D objects na ginagamit sa engineering. Kung ikaw ay nag-aaral ng design o engineering, malaki ang matutulong ng AutoCAD dahil kaya nitong gawin ang halos lahat ng klase ng design task. This make it a powerful tool for students and professionals alike who need a complete solution for their design projects. So next sa mga pros of using AutoCAD is wide industry acceptance and compatibility with various file formats. AutoCAD is widely accepted across different industries, which means that a lot of professionals use it in their daily work. It's compatible with many other software programs, so you can easily share your files with others, even if they're using different tools. Halimbawa, kung ikaw ay magtatrabaho kasama ang ibang mga engineer, hindi ka mahihirapan mag-exchange ng files dahil kayang mag-open at mag-save ng AutoCAD sa mga common formats tulad ng DWG at DXF. This broad compatibility makes it easier for terms to collaborate, ensuring that design workflows remain smooth and efficient, regardless of the tools being used by others. And the third one is well-established community and extensive online resources for support and learning. Since AutoCAD has been around for many years, it has a built large community of users. Dahil dito, madali kang makakahanap ng mga tutorial, forums, at guides na makakatulong sa'yo na matutunan kung paano gamitin ang software ng maayos. Whether you're a beginner or an advanced user, marami kang matututunan mula sa mga online resources na available tulad ng YouTube videos, online courses, or discussion forums. Sa community na to, maaari kang magtanong at makahanap ng solusyon kung may mga problemang kinakaharap ka sa software. This strong online support system makes learning AutoCAD much easier for students and professionals. And lastly, continual updates and improvements by Autodesk to enhance user experience. AutoCAD is regularly updated by Autodesk, the company that created it, to improve its features and performance. Tuwing may bagong update, may mga additional tools at improvements na nilalabas para gawing mas magaan at mas mabilis ang mga design tasks. For example, They add new features that help with drawing accuracy or 3D modeling efficiency. Ang mga update na ito ay nakakatulong hindi lang sa pagpapabuti ng performance ng software, kundi pati na rin sa user experience. Kaya't nagiging mas user-friendly siya, this commitment to continuous improvement ensures that AutoCAD remains a top choice for users in various industries. So let's jump to the cons of using AutoCAD. Number 1 is higher cost compared to some other CAD software options. One of the main drawbacks of AutoCAD is its price. Kung ikukumpara sa ibang CAD software, ang AutoCAD ay medyo mahal. Kaya maaaring maging hadlang ito sa mga estudyante o maliliit na negosyo na may limited na budget. While the features it offers are very advanced, hindi lahat ng users ay kayang magbayad ng malaking subscription fee para dito. However, many professionals still choose AutoCAD because its features justify the cost, especially when they need reliable and comprehensive tools for complex design tasks. Another cons is steeper learning curve for complex features and workflows. AutoCAD is packed with a lot of tools, and while it offers powerful features, it can be overwhelming for beginners. Kung ikaw ay baguhan, maaaring mahirapan kang matutunan agad ang lahat ng mga advanced features at workflows na ginagamit sa AutoCAD. The learning process can be a bit challenging, especially when you need to use more complex tools like 3D modeling or advanced drafting techniques. However, with practice and the help of online tutorials and guides, you can eventually get the hang of it. Matapos ang ilang oras ng pag-aaral, makikita mong mas madali ng paggamit ng AutoCAD. And lastly, it requires a powerful computer system to handle large and complex design efficiently. Another disadvantage of AutoCAD is that it requires a high-performance computer to run smoothly, especially if you are working with large or complex designs. Kung ang iyong computer ay hindi mataas ang specs, maaari mong maranasan ang pagkalag or pagka-slow kapag nagtatrabaho ka sa malalaking files or 3D models. Kaya't parang maging mas magaan at mabilis ang paggamit ng AutoCAD, kailangan mo ng computer na may magandang processor, sapat na RAM, at maayos na graphics card. This could be an issue for students or small businesses who may not have access to high-end computer systems. In conclusion, AutoCAD offers many powerful features, but it also comes with some challenges.
So as per the fifth question, describe the importance of user interface design in AutoCAD and how it has evolved to enhance user experience over the years. So as per the definition, UI stands for user interface. It is everything a person interacts with on a device, app, or website like buttons, menus, screens, and layouts. And it is designed to make using the product easy and enjoyable. So the user interface in AutoCAD plays a vital role in how effectively users can perform their task. A well-designed UI ensures that tools, command, and features are easy to access, which helps beginners learn the software faster and allows experienced user to work more efficiently. So by offering clear navigation, intuitive icons, and customizable layouts, it minimizes frustrations and lets user focus on their designs instead of struggling with the software. So in the end, a good user interface, of course, boosts productivity with accuracy and overall user satisfaction, making AutoCAD a more powerful and reliable tool for professionals in architecture, engineering, or of course in design. So as for the evolution of AutoCAD in 1980s to 1990s, in its earlier version, AutoCAD primarily relied on the command line. So for user input, meaning users had to type specific commands to perform tasks. This approach demanded a significant amount of memorization, as users needed to remember the exact commands and their syntax. While this method was highly efficient for experienced users who were familiar with the commands, it posed challenges for beginners as it was not user-friendly or intuitive, making making the learning, of course, curve and much steeper. So as for the example, the image is shown below. And because of that, in 1990s, AutoCAD user interface underwent a significant improvements with the introduction of menus and toolbars. This evolution aimed to make the software more accessible and user-friendly. Instead of relying solely on type commands like the first one, users could now perform tasks with a single click thanks to the drop-down menu system and toolbar icons. So these visual elements were designed to make more recognizable and intuitive, reducing the need for extensive memorization. So for instance, of course, a user could quickly identify and select drawing tools, editing options, or setting directly from the menus or toolbars, streamlining the workflow and enhancing overall user experience. So in 2000, graphical user interface has been expanded. So it grew more powerful. The software adopted more sophisticated graphical user interface, integrating more tools while enhancing visual appeal. This was part of a larger trend of software becoming more user friendly and less reliant on text-based commands. And of course, on 2009, the ribbon interface has been introduced. This is a major shift, by the way, occurred with the introduction of the ribbon interface in AutoCAD in 2009. So, borrowing the Microsoft Office suite, the ribbon replaced traditional menus and toolbars with the group-related tools. So this change aimed to make AutoCAD's functionality more discoverable and organized by user workflow. So though controversial at first, of course, it ultimately became a standard for AutoCAD's interface. Next is the 2010s era. So in this, customization features has been introduced. So more robust customization options such as customizable workspace and menus where users could create specific environments suited to their projects. So these features allowed for a personalized experience, giving professionals the ability to streamline their workflow. Next is the era within 2010 to 2020. So this is the touchscreen and mobile support. So as technology advanced, of course, AutoCAD began optimizing its interface for mobile and touch devices, allowing for a more fluid and portable user experience. So the UI was refined for touch interaction with easy to use gestures and mobile friendly navigation. So for the last, which is the current trends right now and that is happening, AutoCAD of course continue to focus on the user experience by enhancing its dark mode. So offering better integration with cloud-based workflows and improving the importance of its UI on high-resolution displays. It also incorporates na po the AI-based suggestion. So streamlining workflows and making complex design tasks more intuitive. So that is all for the fifth question.
How do the customization and automation features in AutoCAD contribute to productivity and efficiency in engineering projects? To answer this question, I will categorize it into two features. These are the customizing feature and the automation feature. In terms of customizing feature, we have the first bullet, which talks about the customizing AutoCAD drawing templates. This feature allows to improve the design efficiency by storing settings like the units, scales, layers, and the styles. Yung mga templates ito, nire-reduce niya yung repetitive setup, in which it enables a easier workflow. For example, yung mga architectural templates with the predefined layers for walls and furniture. This allow designers na mag-focus only sa work, not the setup itself, as this creates inconvenience and it is time consuming. Creating templates to fulfill the needs promotes consistency, reduces errors, and enhances the productivity all across the various design fields. In the customization features, this feature not only protects the integrity of the templates, but it also encourages greater efficiency. It allows yung mga users to focus the creative aspects of designs without repeatedly managing the basic settings. Overall, yung mga drawing templates serve as a critical component in enhancing productivity and maintaining uniformity in AutoCAD projects. In CAD design automation, this enhances the efficiency by automating parts of the design process. Kapag na-integrate with the other software, si AutoCAD allows the engineers to interact with the design models before any construction, improving safety, functionality, and environmental impact. Sa AEC or Architecture Engineering and Construction industry, automation can streamline the process, reduce cost, enhance safety, and minimize yung mga costly mistakes na pwedeng mag-lead to delays and inconveniences para sa mga users. As these technologies nowadays, advanced skilled automation engineers, architects, and designers will be essential to fully realize their potential in engineering projects. The integration of cloud services in AutoCAD and its significance in the context of remote work and global collaboration. In terms of the cloud-based CAD, this leverage the power of the internet to deliver CAD services na allow yung mga users to access and modify their designs from any device with internet connectivity. With this, it eliminates yung need for any high-end hardware. Kumbaga, it facilitates seamless collaboration and ensures accessibility and data security. In terms of the integration of cloud services in AutoCAD, this feature significantly enhances the remote work and the collaboration in terms of global. Why so? Through enabling seamless access and real-time updates to design files, yung mga cloud-based tools, inaalaw niya yung mga team members na mag-share ng AutoCAD drawings instantly. With this, it ensures everyone na mag-work sila with the most current version and reducing the risk of version control issues, meaning no need for you to worry about having the different versions because it automatically updates with the latest version up to date. Yung mga features like the markup and annotation, ina-enhance niya yung communication by enabling a direct design feedback na could be helpful for a group projects. This cloud integration adds flexibility, enabling the teams to collaborate seamlessly from any location or any device. This is ideal for today's remote work landscape.
Good day, everyone. So, before I begin, let me introduce myself first. My name is Dominic Sabangan, and today I will be presenting on the topic the role of AutoCAD in education, preparing students for careers in engineering, architecture, and design. AutoCAD has become an essential tool in various industries, and in this presentation, we will explore its significance, applications, and how it prepares students for professional success. So, why should we learn AutoCAD in education? AutoCAD is a globally recognized software used for drafting and design in engineering and architecture. It was developed by Autodesk and has become an essential tool for creating precise 2D and 3D designs. In education, AutoCAD is integrated into the curriculum to provide hands on experience, bridging the gap between theoretical learning and real world applications. By learning AutoCAD, students gain skills that make them industry ready and equipped for their future careers. So, concerning the topic AutoCAD in engineering and design education, AutoCAD plays a critical role in engineering and design education, equipping students with the tools they need to succeed in professional environments. Here's how. So we are here given three bullet points. So the first bullet point is the ability of AutoCAD to create detailed two-dimensional drawings for blueprints and schematics. AutoCAD's two-dimensional drafting capabilities allow students to produce precise technical drawings that serve as the foundation for engineering and architectural designs. These blueprints includes dimensions, tolerances, and annotations which are essential for manufacturing, construction, or assembly. Mastering this skill ensures that the students can accurately convey their ideas to others in the field. So the next bullet point is uh, to build realistic three-dimensional models of mechanical components and architectural structures. So students can use AutoCAD to visualize complex designs in three dimensions. For mechanical engineers, this might mean that creating models of gears or robotic arms, while architecture students may design building exteriors and interiors. This hands-on experience bridges the gap between conceptualization and real-world application, enabling students to refine their designs before production. Lastly, the use of parametric design to ensure accuracy and consistent across designs. Parametric designs allow students to set relationships and constraints between elements of their designs. For example, if a mechanical part's dimension change, other parts adjust automatically to maintain proper alignment. This feature not only minimizes errors but also simulates the precision required in real-world engineering and architectural tasks. So the next topic is the key skills student learns in using AutoCAD. So basically, these are the skills developed with AutoCAD. So one of the most valuable aspects of learning AutoCAD is the development of key skills that are highly sought after in professional industries. So let's take a closer look in these skills that are about to be mentioned. So the first skill is problem solving and creativity. AutoCAD challenges students to think critically about design problems, whether they're figuring out how to fit components within typefaces in mechanical systems or optimizing the layout of a building. Students must develop innovative solutions. This problem solving ability is essential in engineering or design role. So the next one is precision and accuracy. AutoCAD's tool ensure exact measurement and alignment, which are critical in engineering and design. So, for example, in mechanical engineering, even a slight error in a part's dimension can lead to product failure. In architecture, inaccuracies can compromise structural integrity. AutoCAD helps develop a meticulous approach to their work, ensuring every detail is correct. In terms of collaboration, AutoCAD's cloud and file sharing features teach students how to work effectively in teams. So, in real world projects, multiple professionals, namely engineers, architecture, and designers, often collaborate on the same design. So, by working on shared AutoCAD files in class, students gain experience in collaborative design. So, meaning they are being preparing them for team-based projects in their future careers. So the next topic is how AutoCAD prepares students for their jobs. So basically, this is the relevance of AutoCAD to various careers. So AutoCAD training prepares students for a wide range of careers by equipping them with practical job-ready skills. So here's how it applies to specific industries. So the first specific industry is mechanical engineering. So AutoCAD enables engineers to design intricate mechanical components like gears, motors, and robotic systems. It's also used in HVAC systems to create efficient layouts for heating, ventilation, and air conditioning. Automation tools like conveyor belts or assembly lines are often designed using AutoCAD. This makes AutoCAD a staple in industries such as manufacturing, robotics, and energy. In terms of architecture, in the field of architecture, AutoCAD is used to draft detailed floor plans, building layouts, and structural blueprints. Architects rely on it to visualize how buildings will look and function, whether it's a small home or a massive skyscraper. AutoCAD also ensures that designs meet safety codes and construction standards, which is critical in architectural industry. So lastly, the product design and development. AutoCAD is vital for creating prototypes of new products, from consumer goods to industrial equipment. Its simulation capabilities allows engineers to test how parts will interact, ensuring functionality before production. So, for example, in the automotive industry, engineers use AutoCAD to design and refine vehicle components. In aerospace, it's used for aircrafts. So, these skills are directly applicable in industries like automotive, aerospace, construction, and manufacturing. By mastering AutoCAD, students position themselves as competitive candidates in the job market with practical skills that employers are actively seeking. To conclude, we are left with the question why AutoCAD is essential as a learning part for students. So, in conclusion, AutoCAD is an essential tool in education which prepares students for careers in engineering, architecture, and design. By learning AutoCAD, students can develop technical problem solving and collaborative skills that are directly applicable to professional work. It bridges the gap between theoretical learning and real world application, making it a cornerstone of modern engineering and design education. As the demand for skilled professional grows, AutoCAD will continue to play a crucial role in shaping the future of education and industry. Thank you.
Now, let's talk about the challenges and limitation of using AutoCAD in complex 3D modeling projects, particularly in comparison to specialized 3D CAD software. AutoCAD's 3D capabilities are limited due to its focus on 2D drafting, making it difficult to create and manipulate complex shapes, particularly organic forms, preform surfaces, and intricate assemblies. Ang ibig sabihin daw nito na ang AutoCAD ay mas mahusay sa pagguhit ng mga plano sa papel o tinatawag na 2D, kaysa sa paggawa ng mga bagay na may taas, lapad at lalim o mas alam natin sa tawag na 3D. Mahirap gumawa ng mga hugis na hindi regular, tulad ng mga hugis na parang bato o mga dahon. Kapag maraming parte ang isang 3D na bagay, maaaring maging magulo at matagal ang pagsasama-sama nito sa AutoCAD. May mga ibang programa na mas espesyal sa paggawa ng mga bagay sa 3D, tulad ng 3ds Max o Blender. Mas madali at mas mahusay ang mga ito para sa mga komplikadong 3D na proyekto. Sa simpleng salita, kung gusto mong gumawa ng mga bagay na may talagang magandang 3D na itsura, mas magandang gumamit ka ng mga programa na talaga namang para sa 3D. AutoCAD's large 3D models can cause slow performance and sluggish rendering times, affecting project timeliness and efficiency. AutoCAD's large 3D models can significantly affect performance, causing slowdowns and sluggish rendering times. This can result in slow panning, zooming, object manipulation delays, and extended rendering times for high-quality images or animations. These issues can hinder project timeliness, workflow efficiency, productivity, and potentially cause delays. AutoCAD may lack industry-specific tools and features found in dedicated 3D modeling software, which are essential for tasks like advanced simulation, product design, and architectural visualization. Sa pagsusuri ng mga kakayahan ng AutoCAD sa 3D modeling, napansin na kulang ito sa mga particular na tool at tampok na kinakailangan sa iba't ibang industriya.
Halimbawa, ang mga tool para sa stress analysis at fluid flow simulation na mahalaga sa mga larangan ng engineering ay hindi gaanong detalyado sa AutoCAD kumpara sa mga dedikadong software para sa 3D modeling. Dahil dito, limitado ang kakayahan ng AutoCAD na magsagawa ng mga komplikadong pagsusuri at magdisenyo ng mga produkto na nangangailangan ng mataas na level ng pag-aaral sa mga aspetong ito. AutoCAD may have workflow efficiencies such as limitation in data exchange, collaboration, and version control, which can hinder efficient teamwork and project management compared to specialized software. These issues can lead to data loss, communication bottlenecks, and difficulty tracking changes. AutoCAD's built-in version control features may be less sophisticated, making it difficult to manage design versions and prevent conflicts. This limitation can significantly impact project efficiency and increase the risk of errors and delays, particularly in collaborative projects involving multiple teams, members, and software applications.
So, good day everyone. So, today I will discuss an exciting topic. So, the future of AutoCAD with the integration of AI powered tools and features. So, as technology advances, AutoCAD is transforming to a smarter, more intuitive software, paving the way for the next generation of design and engineering. So come and join me and explore how AI or automated intelligence, machine learning, augmented reality, and other innovations will reshape the future of this essential tool. So, AutoCAD is already incorporating artificial intelligence to make workflows faster and more accurate. For example, AI driven features can analyze design patterns, suggest optimizations, and even protect potential flaws or conflicts in drawings. This means that engineers can focus more on creative and strategic work rather than spending hours in revising or searching for errors. So AI can also automate repetitive tasks such as dimensioning and layout adjustments, saving time, especially on large-scale projects. Imagine how much faster and more precise projects will be in the future with these tools. So, think of it. AI isn't replacing engineers, it's enhancing their capabilities. So, now let's talk about the enhanced visualization through AR and VR. So, another major development is the integration of augmented reality or AR and virtual reality or VR. These technologies will transform how we interact with designs. For instance, architects will be able to walk through virtual versions of buildings to elevate layouts and spatial relationships. Mechanical engineers can interact with virtual prototypes to test functionality before production even begins. This immersive approach will allow designers to identify potential issues early and refine their ideas in ways that weren't possible before. Can you imagine being able to explore your design as if it already exists? Concerning the topic cloud computing and IoT integration, cloud computing and the Internet of Things or IoT are becoming central to the future of AutoCAD. With cloud computing, collaboration and data management will continue to improve. Team members will work seamlessly on projects in real time, no matter where they are in the world. IoT will take a step further. Imagine using a real time sensor data from a machine to inform your design decision in AutoCAD. Engineers could optimize designs on how a machine performs in the real world, making projects more efficient and innovative. So, this means that there will be smarter designs, more informed decisions, and better outcomes for everyone involved. So, in the topic machine learning for predictive modeling, machine learning is another technology shaping AutoCAD's future. By analyzing historical design data, machine learning can help users to predict trends, suggest materials, and estimate costs. For example, if you're designing a mechanical part, machine learning algorithms could recommend the most efficient materials or predict potential wear and tear over time. This will allow engineers and designers to make informed decisions early in the process, saving time and resources. Automation and customization at new levels. Future versions of AutoCAD will also bring advanced automation and customization. Users will be able to develop custom workflows tailored to their industries. For example, a mechanical engineer might automate the creation of specific parts or assemblies, while an architect could customize workflows to streamline their building designs. This level of adaptability will make AutoCAD even more powerful, enabling professionals to work more efficiently than ever before. Sustainability and eco-friendly design. With growing concerns about sustainability, specifically in terms of climate change, which are now obviously seen in our current environment, AutoCAD is also likely to support eco-friendly engineering practices. AI-powered tools could help designers assess environmental impacts, energy efficiency, and life cycle cost of their projects. For instance, engineers could simulate and analyze how materials impact carbon emissions or energy usage, enabling them to create sustainable and eco-friendly designs. This aligns perfectly with the global push for more sustainable development. So, in conclusion, the integration of AI or automated intelligence is and advanced technologies in AutoCAD is revolutionizing design and engineering. With AI-powered design assistance, immersive AR, VR tools, real-time collaboration through cloud and IoT or Internet of Things, predictive modeling, enhanced automation, and a focus on sustainability, AutoCAD is not just keeping up with the future, it's defining it. These advancements will make workflows smarter, faster, and more innovative, ensuring AutoCAD remains a cutting edge tool for years to come. The future of design and engineering is bright, and AutoCAD is at the forefront of this transformation. Thank you for listening. Have a great day ahead. God bless you.